morning to all of you. After the introduction lecture, today we are moving to start your class 11's first chapter in my channel. That is motion in a straight line. Already we have discussed what is physics, how to study physics, what are the basic terms of physics, and I also advise you to go through some basic concept of physics yourself. And today we'll start the lesson motion in a straight line. Motion in a straight line. You please note it down. This is the chapter number 3 of NCERT textbook class 11 physics, that is motion in a straight line. We have already discussed a couple of things, basic things regarding the speed, distance, displacement, or listing, but in this chapter we will discuss in brief about all of them. Now, motion in a straight line, once you study these things in physics, you'll find that this is a part of kinematics. This is the part of kinematics. This chapter, motion in a straight line, this chapter will be a part of kinematics. And kinematics, what does kinematics means? Kinematics is a branch of physics which deals with the motion of an object, but not about the region behind it. I think you have got it. What does kinematics means? Kinematic is the branch of physics where we study about the motion of the object, but we don't study about the cause of the motion. Is that clear? If I consider, suppose I am taking a body here. This is a body. This is a body we have considered. Now, right now this body is at rest position. This body is not moving anywhere. This body is not going anywhere. Now, if I apply an external force here, suppose I am applying here a force F. That means I am applying external force. Then what will happen? This body will start moving in a straight line, or the body will start moving ahead. Why but the body is moving? Because body is moving because I have applied a force behind it. And then as we applying the force on the body will change its position. And once the body will change its position, so there will be motion of the body. Now, what exactly kinematics are going to apply in this particular diagram is that in kinematics we will study about the position of the body. How the body is changing position. Changing position means how the body is getting motion. But we will not study about the reason. That means we will not study about this force, because we have already applied a force, and we have applied the force. That is why this body has changed its position. So we will not study in kinematics about this force or this region for which the body has changed its position. Understand that? So you can write that kinematics is the branch of physics. Kinematics is the branch of physics. Kinematics is the branch of physics. Keep writing. Kinematics is the branch of physics where we study about the motion or position of the object or body, but we don't study about the reason behind it or about the cause who produces the motion. It is the branch of physics. It is the branch of physics where we study about the position of an object but we don't study about the reason behind it. This is a very important word, definition. It is about kinematics. So you can write down, this is kinematics. So what is kinematics? Kinematics is what? It is the branch of physics where we study about the position of an object, but we don't study about the reason behind it. But there is another branch of physics where we study about the reason behind it. That is called dynamics. This is kinematics. In kinematics, we study about the only position. You kindly note it down. Now, in this case, this straight line motion of a body is also known as rectilinear motion. Rectilinear. Okay, this straight line motion of a body is also known as rectilinear motion of a body. Am I clear? So you please note it down, and you have come to know about kinematics, what is happened and what we do in this case. Now next things in this chapter will come here. We have already discussed that what is motion. If I ask you what is motion, that is a very important topic. Motion you have studied in the class 9, and I have also discussed in the in my introductory lecture. So what is motion? If I ask you normally, what is motion? That motion means a body should be changing its position continuously. If a body is changing its position continuously with respect to time, then this will be known as motion. You can write down, if a body is continuously changing its position, with respect to time, then the body is said to be in motion. Understand? This is the proper definitions of motion. You can write down that if a body is continuously changing its position with respect to time, then the body is said to be in motion. Is that clear? Suppose I'm standing here and I am changing my position continuously with respect to time, then I will be said that I am in motion. Am I clear? So one more thing will come in this case, that if a body is not changing its position continuously with respect to time, suppose a body is not changing its position with respect to time, then it will be called its rest position. What position? Rest position. We also should know about the rest position. What is rest position? Rest position's definition would be quite opposite of the definitions of the motion. What do you write? If a body is not changing its position continuously with respect to time, then the body will be said in rest position. In rest position, the velocity of the object becomes 0. Am I clear? In rest position, the velocity of the body becomes 0. So is that clear, these two things? This is a very basic starting of the physics of this chapter, where we are studying about the kinematics or dynamics about these things. I have told you what is kinematics, and motions also I have declared what is motion. That body should be changing its position continuously with respect to time, then this body will be said in motion. There are so many types of motion: uniform motion, non-uniform motion, circular motion. Okay, I have discussed you in my introductory lecture about the types of motion, but still we're going to discuss briefly about them. Okay, so rest positions and motions is clear to you. That most importantly, in if a body is in rest position, that we will be sure that the velocity at that particular point of the object is going to be definitely zero. Now let's come back to the next topic, that is your uniform motion and non-uniform motion. You can check my previous video where I have told you what is uniform motion, what is non-uniform motion. That in case of uniform motion, a body is traveling same equal amount of distance in equal amount of time interval, and in case of non-uniform motion, a body is traveling equal amount of distance in unequal interval of time. So you mind these two words, that equal amount of distance in equal amount of time. That means equal distance, equal time is surely going to be your uniform motion. On the other hand, unequal distance and equal amount of time, remember my point, that unequal amount of distance and equal amount of time is going to be your non-uniform motions. If I arrange this definition, so I can say that if a body is traveling unequal amount of distance in equal number of time, then this will be, the body will be said in non-uniform motion. Circular motions, we know, if a body travels in a circular direction or if a body travels in a circular path, then this body will be said in circular motion. And we will discuss later on about the two main figure of circular motion, that is centripetal force and centrifugal force. That is a very important concept of physics, especially in motion. Centripetal force and centrifugal force we'll discuss later. Now let's discuss about the next topic of us, that is though I have mentioned in my previous video about distance and displacement, but definitions I have not given. So you write now the definition of distance. Definitions of distance you write. I will just tell you the definitions in this video, as I have mentioned clearly what is distance in the previous video. Right, the actual part, traveled by a body is called the distance. The actual path traveled by a body is called distance. It is a scalar quantity. And its SI unit is meter per second, and it is expressed as sometimes we write it as S, and it is expressed as S. Remember, it is your distance. The actual path traveled by a body is called distance, and it is a scalar quantity. Distance is a scalar quantity, and it is its unit is meter. There's no meter per second. The distance will be in meter or centimeter. Its unit is meter. Okay, and it is your expressed as S. Next, displacement. Distance you have understand. I have discussed in a previous video very nicely. You have written it. Pause the video and write it clearly. Next, I will come back to the displacement. Displacement, we have to discuss a couple of things about displacement in this video also, though I have told you. Displacement, right? The minimum distance, travel between initial point and final point is called the minimum distance traveled between initial point and final point is called displacement. Is called displacement, and it is, you can write, it is a vector quantity. It is a vector quantity. Remember, distance was scalar and displacement is vector quantity. So in this case, the unit, it is a vector quantity displacement, and the unit will be same as distance. And how displacement is expressed? Distance displacement is expressed sometimes d x y z, x or y. Sometimes we express displacement like that. So this is the definitions of the distance and displacement. But sometimes displacement has got also called a shortcut of distance in physics, and there is a basic concept behind it. I am going to discuss it now. You just pay attention to it. That most of the time distance and displacement are not same. Remember, most of the time distance and displacement are not same, but question arises when distance and displacement are same. Am I clear? You can write when distance and displacement are same. The magnitude of distance and displacement are same if the body is moving in a straight line. Unless the body is not moving in a straight line, the magnitude of distance and displacement are not going to same. If I consider two-way, suppose I am taking a straight line like that. It is a straight line. Suppose it is coming from x. It is xy. It is xy is going to be a straight line. I have considered supposed to be. Now in this case, if I consider it is a point, suppose A, it is a point, suppose B, it is a point, suppose C. Now if I tell you that distance from x to A is 10 meter, A to B is again 10 meter, B to C is again 10 meter, and C to Y is again 10 meter. Have you got it? Just pay attention to the diagram. XY is a straight line. I have supposed to be, where XA, distance between X and A is going to be 10 meter. Distance from A to B is similar 10 meter, 10 meter and 10 meter. In this case, if you want to find out what exactly the distance is, if I find the distance here, if I find the distance in this particular case, what will be the distance? Distance will be what? XA plus AB plus BC plus CY. If I add all of them, then I can find the distance. That is going to be your, how much is the distance will be here? 10, 10, 10, 10, that is 40 meter. This 40 meter is going to be your distance. But in this same case, if I want to find the displacement right here, if I'm going to find the displacement right here, how can I find the displacement here? Displacement, I told you that it is the distance traveled between the minimum distance traveled between the initial point and final point. So here, suppose it is the initial point, suppose 0, and final point, similarly it is going to be your 40. So displacement will be what? The final point minus initial point. What is the final point? Final point is your 40 meter and initial point is 0. So at the same time, the displacement is also going to be your 40 meter. Now we can confirm one thing, that when a body is traveling in a straight line, then only the magnitude of distance and displacement are same. But to be same magnitude of distance and displacement, the body should be in a straight line. You can note it down, or you can write these things and write that the magnitude of distance and displacement will be same if the body is traveling in a straight line. Am I clear? What will happen if a body is moving in a non-straight line or in a rectangular line or in a circular line? Will the magnitude of distance and displacement will be same? No. Am I clear? How it is not going to be same? I am just telling you. So suppose it is the xy, again same figure I have drawn. This is xy, this is the point A, this is the point B, this is the point C. Again this is 10 meter, this is 10 meter, this is 10 meter, again this is 10 meter. So this is the x to a 10 meter, like that. Up to here we have already found that to the total distance here will be 40 meter. But somehow this body has moved back from Y to C again. This body has moved back from Y to C again. That means this just again come back from where? Y to again C. Understand? That means you can consider that body gone from X to Y, and again after arriving at the Y point, the body has again come back to the point C. So in this case, what will be the total amount of distance traveled? Total amount of distance traveled will be 40 meter. In this case also, distance is going to be how much? Total distance it is traveling from X to Y. Okay, then it will be again the total distance is traveled from here will be 40 meter. Understand? Na? But displacement, in this case displacement is not going to be same. Displacement, how it is not going to be, distance will be here exactly 40 meter. Okay, X to Y is 40 meter, and after going to 40 meter again it has gone to 10 meter. That means total distance it will traveling will be how much? 50 meter. Total amount of path it has traveled, that will be what? Total amount of distance will be here 50 meter. From X to Y 40, again 10 meter extra, it has got 50 meter. But what will be the displacement? The displacement is going to be, displacement is not going to be same in this case. Why? Displacement will be what? How much? That this is the initial point and this is the final point. The minimum distance travel between initial point and final point. Now in this case, how can you find out the displacement? It is very simple to find the displacement as well. The displacement will be in this case that total distance from here to here is how much? 40. Okay, total distance traveled in this case will be how much? 40 meter. This is 40 meter. And then how much it has come back after this 40 meter? It has taken how much? 10 meter. That means displacement will be how much? 30 meter. Am I clear? So have you got this point? Total distance how much? 40 meter. How much it has again come back? 10 meter. So how much will be the displacement? Displacement will be 30 meter. Or we can find the displacement, I can also find by joining these two. How much? From X to C. From X to C, how many distance? How many displacement is 10, 10, 10, 30. That means you can see the displacement in this case is 30 meter, but distance in this case is 50 meter. Can you see that this magnitude of distance and magnitude of displacement are not going to be same? Why? Because this body is not moving in a straight line. You can see that body is first of all it is one in a straight line, but it come back to again another point. Am I clear? So we can confirm that, or we can clear that the magnitude of distance and displacement are not always same. Magnitude of distance and displacement are same only when a body is moving in a straight line. That is the important point. You can write or you can note it down. Next, after distance and displacement, we can go to the speed and velocity. I have told you what is speed and velocity in the previous class, but again I am telling you, you write one question, what is rectilinear motion? You write a question, what is rectilinear motion? It's a homework for you. What is rectilinear motion? I have just mentioned what is rectilinear motion. After that, speed and velocity, I have just told you in the previous class what is speed and velocity. That is speed will be defined as distance by time, and velocity will be defined as displacement by time. In the next class of the video we'll discuss all these things, and whatever we have discussed today about this chapter, we have just begun your chapter motion in a straight line. Many more to come. In the next video we'll discuss more thing. For today, thank you so much.